In question number 26, we have integral from 0 to pi by 4 sin x cos x upon cos power 4x plus sin power 4x. Now, how will we handle this? Let's take a look at the solution. So, sin x cos x upon cos power 4 plus sin power 4. Can I simplify this somehow using, maybe let us say first of all, this cos power 4 plus sin power 4, one of the ideas is, okay, we can reduce this to a lower power, yes. That is, we can write sin square plus cos square square minus 2 sin square x cos square x, but then that will be 1 minus 2 sin square x cos square x, even complicated form than what you have in the numerator, right? So that will not work wonders. What else? What else? If you observe this 0 to pi by 4 gives you some kind of a hint. What kind of a hint? The NCERT people are lovely people, right? So if they have given 0 to pi by 4, they want you to go in the direction of maybe tan, sec, yes? Had they only wanted you to go between sin and cos, they would have given limits from 0 to pi by 2, maybe, who knows? Oh, is that the way to think? No, that is one of the ideas, but that is true for NCERT people. That's not true in general. In general, you'll have to think of integrating this whole expression. And integrating this whole expression will be an issue until unless you realize, okay, this cos power 4x is creating a lot of problems. Can I divide with this cos power 4x and see where does that take me? The whole denominator is creating problem, but then let's divide with cos power 4x. What does that give me? 0 to pi by 4 dividing by cos power 4x, in the numerator will be having sin x upon cos cube x, right? Give 1 cos x to that, that becomes sin x upon cos x is tan x. There cos square x still remains in the denominator, that will be equal to sec square x over here. This is 1 plus sin power 4 upon cos power 4, which will be tan power 4x dx. And now can you observe that, okay, this is 0 to pi by 4, that's okay. This is tan x into sec square x, which is okay. This is 1 plus square of tan square x dx. Square of tan square x. This step has been obtained by dividing numerator and denominator by cos power 4x. And after that, we have simply written it as this. And the moment you write it as this, can you see that put tan square x is equal to t implies 2 tan x times sec square x dx will be equal to dt. The numerator is this, which will be equal to dt upon 2. Yes or no? Yes. What about the lower limit? Lower limit says x equals 0. That tells me, okay, t will be equal to tan square 0, which is 0. Upper limit says x equals pi by 4. That tells me t will be equal to tan square pi by 4, which is 1 square, which is 1. So you have found the lower limit at the upper limit as well. Yes. And with this in mind, therefore I simplifies to what? Integral of this numerator becomes tan x sec square x dx is dt upon 2. This is 1 by 2 dt. In the denominator you have 1 plus tan square x, which is t and its square. What else? Limits, lower limit from 0 to upper limit 1. This is what you get. And now the question becomes very simple. Yes? Okay. So 1 by 2 is okay. Integral of dt upon 1 plus t square is nothing but tan inverse t from 0 to 1 is what I get. 1 by 2 is okay. Tan inverse 1 will be pi by 4 minus tan inverse 0 is this. This becomes pi by 8. And that is my required answer for this 26th question, as you can see over here.